आज इस वीडियो में हम गुलामान-ए-अब्बास स्कूल प्रिलिमिनरी एग्जामिनेशन 2021 10 फिजिक्स थ्योरी एंड एटीपी पेपर्स को सॉल्व करेंगे. So let's come to our first question of this year. So in question number 1, we have Sarah ties one end of a rope to a tree. She holds the other end of the rope and moves it up and down. What type of waves are produced? So, as we can see, the rope is moving in the form of crust and trough, and the particles of the wave are moving perpendicular to the direction of propagation of wave. So, these type of wave produced in a rope are known as transverse waves. So, the correct answer in this question is option B. Then we have question number 2. The figure below shows green and black waves, which is the frequency of what is the frequency of each wave. So we have the wave number 1 and wave number 2. So let's recall what is frequency. So frequency is the number of waves in a unit time. The waves formed in a unit time is called frequency. So let's see in wave number 1 how many waves are produced in 1 second. So this is 0 second and this is 1 second, and between 0 and 1 second let's count the number of waves. So the wave starts from point A, and the point a wave ends at this point B. The next wave ends at this point C. Then we have another point wave, and this is the wave ending in 1 second. So let's count. We have 1, 2, 3, and 4. So we have 4 waves in 1 second. So 4 waves in 1 second, the frequency of this wave becomes 4 hertz. Similarly, let's count the number of waves in 1 second. So this is 0 second, and here we have 1 second. So if we count the number of waves, a wave starts from this point, ends at this, and the second wave starts this at this point and end at this point. So overall, we have 2 waves in this diagram, 2 waves divided by 1 second. So the frequency of this wave becomes 2 hertz. So let's see the correct answer. We have 4 hertz in wave 1 and 2 hertz in wave 2. So the correct answer is option A. So let's come to our next question, that is question number 3. In question number 3, which of the following is not an example of simple harmonic motion? कौन सी examples does not perform the motion simple harmonic motion? So in option D, we have the motion of a spring mass system that we already have learned in our textbook and in our physics course, that the spring mass system and simple pendulum that is present in option C. These two are the best examples of a body performing simple harmonic motion. Similarly, let's see option A and B. So in option B, we have a swaying of cradle to put babies to sleep. So this is the cradle that moves in a vibratory motion, and the motion is exactly the same that a ball rolling in a bowl, or the motion possessed by a spring mass system or pendulum. So we have the correct answer in option A, the rubber band's movement in a slingshot. So the movement of rubber band is not the type of simple harmonic motion. So the correct answer for this question number 3 is option A. Let's move to our next question. And let's see what we have in our question number 4, 5, and 6. A mechanical wave has a frequency of 2 kilohertz. So we have got our frequency, the wavelength of 35 centimeters, and how long will it take to travel a distance of 1.5 kilometers. So this is, we have our distance. How long means we have to find the time, we have frequency, and we have wavelength. So frequency would become 2000 hertz, 2 kilohertz is 2000. Wavelength lambda is 35 centimeter, that makes 0.35 meters. And let's first of all find the velocity of the wave from this equation, from this given data. So for velocity, we know that velocity of the wave v is equals to lambda f, where lambda is 0.35 and the frequency is 2000. So let's multiply 2000 with 0.35. So 0.35 times 2000 is 700. So we have velocity of the wave 700 meters per seconds. And we have to find the time, and we are given with the distance. So let's apply distance is equals to velocity multiplied by time. So the time will be equals to distance covered divided by velocity. So the distance is 1500 meters divided by velocity is 700 meters per second. So let's divide 1500 with 700. So the correct answer is 2.14. So the time is 2.14 seconds. So the correct answer will be 2.1 seconds, that is in our option B. So let's see question number 5. If the length of the pendulum is doubled, so if we double the length of the pendulum, what will be the change in its time period? So we know that the time period is equals to 2 pi square root L over G. From this given formula, we know that time period is directly proportional to square root of L. So if we double the length, so it will become 2L. So the time period will be increased by the factor of square root 2. So square root 2 is equals to 1.14. So time period will be increased by a factor of 1.14. So the correct answer in this question number 5 is option C. Then we have question number 6. Which of the following will be equal to 0 bell? So we have intensities in our options, and we have sound level in our question. So 0 bell is actually the sound level of faintest sound. We know that the faintest sound that can be heard by us is 10 raised to the power minus 12 watt per meter square, that is equal to 0 bell. As the intensity of the sound increases, its value in bell also increases. So the correct answer in this question number 6 we have is option B, 10 raised to the power minus 12. So these were the question for 5 and 6. Let's move to our next question. We have question number 7 and 8. In 7, how does the sound travel from its source to your ears? So sound, as we know that it is a type of mechanical waves and longitudinal nature, and these type of wave require magnitude to propagate through any they require medium to propagate through any medium. So the sound traveling in air actually changes in the air pressure. So correct answer is option A. When the sound travels in air, it increases the pressure, air pressure in between the air molecules, where it forms compression, and decreases the air pressure when it forms rarefactions. So the correct option is option A. Question number 8. We have to tell the one of the use of ultrasound. So we have studies we have already studied many uses of ultrasound in our SLO. So one of the use of ultrasound is to remove blood clots from our formed in arteries. So option D is the correct answer in this question number 8. So let's quickly see question number 9. In this question, if a ray of light falls perpendicular to the surface of the dense medium, so this is our incident ray that makes angle of incidence equals to 90 degrees. And as we can see, the refracted ray pass straight through it, and the emergent ray also passing straight because it makes 90-degree in the glass air boundary. So what happens when this phenomena or this situation occurs? So as we know that whenever light enters from rare to dense medium, its direction of propagation changes as well as its speed. So in this special case, when incident ray strikes with a 90-degree, so there is no change in the direction of propagation of wave, but still the wave will be slower in glass as compared to air, because glass is the denser medium as compared to air. So it will change its speed but not the direction. So we have correct answer, that is option C. The refracted ray will be slower as compared to incident ray. So this was our question number 9. Let's move to our question number 10. Which instrument is shown below? So we know that this is our simple magnifying glass. This magnifying glass is used to enlarge object, and it consists of a single convex lens. Similarly, compound microscope and telescope, these two involves more than one lens. One is objective lens and one is the eyepiece. So in periscope, we use a pair of prisms. So this is the incorrect one. So last option we have is a simple microscope. That is the correct answer in this question. So magnifying glass or a simple microscope are the same things that uses convex lens to enlarge the image of the object. So let's see the question number 11. In the given figure below, which two properties of or which two phenomena of light are shown? So this is the phenomena in which light is entering from air to water, and it changes the propagation direction of propagation of wave. So this phenomena is the refraction of light. Similarly, in other phenomena, that is light traveling from water to air, making an angle greater than the critical angle, and it bounces back into the same medium. So this phenomena shown in this diagram is the total internal reflection. So these are the two phenomena that are present in this diagram. So the correct answer is option D, refraction of light and the total internal reflection between water and air. Let's see question number 12. In question number 12, we have a diagram of a convex lens in which image is formed, and with the help of these three rays, we have to identify these 2 points. So as we know, if we can recall the rules of image formation, so this parallel incident ray, we know that it always pass through focus. So it's mean this point through which the first ray incident ray is passing is our focus. Similarly, if we can see the second incident ray I2, the incident ray strikes at a point and passes straight through it. So we know that this point is known as optical center. So the one is optical center, while the second is the principal focus. So option C is the correct answer. Let's move to our question number 13. The speed of light through glass is 2 exponent 8 meters per second. So this is the speed of light in a medium, that is glass. Speed of light in air is 3 exponent 8, that is represented by C. And we have to find the refractive index of glass. So if we recall the formula of refractive index, that is equals to C over V. So the value of C is 3 exponent 8 and the value of V is 2 exponent 8. So 3 over 2 will become 1.5. So the correct answer for this question number 13 is option D. Let's see question number 14. In question number 14, we have a ray diagram of a diffracted eye because the incident ray, refracted rays meet in front of the retina. So this diagram shows that image is not formed clearly. In front of retina is formed in the short-sighted person. The person is short-sighted. To cure this short-sighted person, we use a diverging lens, so that diverging lens in front of the eye, so that this point should move away, further away, and finally meets on the retina. So this diverging lens is our concave lens. So the correct answer is in option A, that we use concave lenses to cure this type of disease. Then we have question number 15. An object is placed 14 centimeter in front of a concave mirror. So this is our position of object P. Then the image is formed in front of the mirror 5.8 centimeters. So this is the position of image. What is the focal length of the mirror? So we have to find the focal length of the mirror. So image is formed in front of the mirror. It's mean this is the real image formed by the mirror. So let's apply the mirror formula. 1 over f equals to 1 over p plus 1 over q. So finally the formula for f equals to pq divided by p plus q. So value of p is 14 multiplied by 5.8 divided by 14 plus 5.8. So the value of focal length is 4.11 centimeter. That is option A is the correct answer. Let's move to our question number 16. In question number 16, if an incident ray falls on the surface along the normal. So this is the incident ray that is moving or striking the surface, making parallel to the normal. Which of the following will be the reflected ray in such cases? So we know that when incident ray strikes at the 90-degree and to the surface, so the reflected ray will also bounce back with the same angle. So option A or ray A will be represented as reflected ray. So option A, that is ray 1 or ray A, is the correct answer. Then we have question number 17. The ratio of speed of light in a vacuum to the speed of light in a material is called refractive index. So, as we have solved a numerical problem in the above questions, so by using the same formula, n is equals to c upon v. So, this is the definition for the refractive index. Let's see question number 18. So this is our question number 18. Pick the correct statement. So this is the diagram and we have to identify the correct statement. In this diagram, we have two oppositely charged plate A and B, and a charge Q, positive charge Q is present between them. The electric field lines are from plate A towards plate B. So let's apply a concept here that whenever the charge moves in the direction of field, energy is supplied by the charge. Similarly, when a charge is moved opposite to the direction of electric field, the energy is supplied to the charge. So in condition A, as it moves from A to B, energy will be supplied by the charge. This is the correct one because charge is moving in the direction of electric field. In part 2, as it moves from A to B, energy will be supplied to the charge. This is incorrect because from A to B, it is the direction of electric field. In condition 3, as it moves from B to A, energy will be supplied by Q. This is incorrect because from B to A, it will be opposite to the direction of electric field. As its charge move from B to A, energy will be supplied to the charge. This is the correct one because when charge move opposite to the direction of field, energy should be supplied to the charge. So condition 1 and 4 is correct. So option B, 1 and 4 is the correct answer. Question number 19. The quantity of charge stored between the plates of the capacitor is 5 coulomb. So this is we have charge Q and the potential across the plates of the capacitor is 100 volt. We have to find the value of capacitance. So we know that capacitance is equals to Q over V. Q is 5 and voltage is 100. So capacitance would be 0.05 farad. Option C is the correct answer. 20. Which of the following statement is true about the behavior of a neutral object near a charged object? So let's say this is our neutral object and we have a charged object. This charged object could be positive or could be negative. So we know that between charged body and a neutral body, there is always attraction because attraction occurs between two charged bodies when they are oppositely charged, and attraction occurs between two bodies when one is neutral and the other is charged. So, what will happen? They will be attracted, it will be attracted to the charged object and it will be repelled by the negatively charged object and attracted to a positively charged object. The charged object will have no effect on it. So option B is the correct answer because these two bodies will show attraction between them. Then we have question number 21 and 22. According to Coulomb's law, what happens to the attraction between two oppositely charged objects when the distance between their separation increases? So, if you recall the Coulomb's law, this Coulomb's law states that F equals to K Q1 Q2 over R square. So force is directly proportional to product of charges, and its force is inversely proportional to square of the distance. So if we increase the distance, the force between them decreases. So their attraction or repulsion decreases. So let's see the option. Their attraction increases. So this is incorrect. Their attractions remains unchanged. This is incorrect. The state of the attraction cannot be determined. So option B is the correct answer, that their attraction will decrease. Then we have two oppositely charges, 400 microcoulombs and 100 microcoulombs, and the distance between them is 1 meter. What is the force of attraction between them? So let's apply the same formula. F is equals to K, that is 9 exponent 9, multiplied by 400 multiplied by 100 microcoulomb. So 10 minus 6 and minus 6 will become minus 12, divided by 1 square. So let's simplify this expression. 9 exponent 9, 4 exponent 2, and 10 raised to the power 2, 10 raised to the power minus 12. So 9 fours are 36, and by adding these powers of 10, 9 twos 9 plus 2 plus 2 is 13, and 13 minus 12 is 1. So 10 raised to the power 1 will be equals to 360 newtons. So the correct answer for this question number 22 is option D. Let's see what we have in our question number 23. So this is our question number 23. These two balls, plastic balls, are repelled by each other, so we have to identify that which option is correct. Both of them possess same kind of charge. This is the correct one. Both of them are oppositely charged. No, this is incorrect, because opposite charge always attract each other. Both of them are positive and both of them are negative, so we don't know what type of charge, both are positive or both are negative, so we don't know about that. So the correct answer would be option D, that states that both of them possess same kind of charges, either it is positive or it is negative. Let's see question number 24. An ammeter and 18 ohm resistor connected in series with a battery. The reading on the ammeter is 0.03 ampere. The resistance of the battery and ammeter can be ignored. We have to find the value of EMF of the battery. So current reading is 0.03, that is I, and the value of resistance is R, 18 ohms. So we have to find the voltage, that is equal, so V is equals to IR. Let's multiply 0.03 multiplied by 18. So the product is 0.54 volts. So the correct answer will be in option A. Let's move to our question number 25. The circuit diagram shows a battery and four lamps. All the lamps are lit. If one lamp fails and all remains lit, which lamp will be failed? So इन चारों बल्ब्स में से अगर कोई एक बल्ब फेल हो जाता है, सो उसकी वजह से बाकी तमाम बल्ब्स ग्लो करने चाहिए, तो वो कौन सा बल्ब है? सो दैट बल्ब इज आर ऑप्शन बी. अगर इस बल्ब को हम डिस्ट्रॉय कर दें, डैमेज कर दें, सो करंट विल बी इजीली passing through this path. So the correct option in question number 25 is option B. Let's see question number 26. So this is our question number 26, in which X and Y are two terminals and ammeter is connected to the live wire and a resistor or a load of 24 ohms. So, and voltmeter is connected in parallel. Which pair of reading cannot be obtained when a suitable power supply is connected between X, Y? So we know that the value of current and the voltage, the product of these uh, resistors should be equal to V over I. So we have to find that the ratio V over I should be equals to 24. So here we have V is equals to 12 divided by 0.5. The ratio would be equals to 24 volt. Similarly, voltage is 12 and the current is 2. So we have 6 ohm resistor. So this is the correct option. Voltage and current reading could not be these 12 volts and 2 ampere in this case. In all these three options, the value of V over I would be equals to R, that is 24 ohms. So the correct answer is option D. Let's see question number 27 and 28. The diagram shows a part of an electric circuit in which these two resistors are connected in series and their equivalent resistor would be equals to 10 ohms. Similarly, in this diagram, we have 5 and 5 ohms connected in series, and their total would be equals to once again 10 ohms. So this means these two pairs of resistors are connected in series, and their equivalent is connected in parallel combination. So current of 6 ampere is coming towards this point, and the total resistance to the upper part is 10 ohms. Similarly, the total resistance in the lower part of the circuit is 10 ohms. So if the resistance are equal, then the current would be divided into equal parts. So 3 ampere current would pass through this, and 3 ampere will current pass through this. So what is the sum of currents in 2 ohms and 5 ohms resistor? So 2 ohms, the current in the 2 ohms will be 3 ampere, and the current in this 5 ohms will be 3 ampere. So the sum of this current is 6 ampere. So the option D is the correct answer. Question number 28 is the simplest question in which the unit of potential difference is asked. So the correct answer is option C. The potential difference is always measured in volts. Then we have question 29 and 30. The earth wire in electrical appliances is connected to which part of that appliance? So the correct answer is metal case. The earth wire are always connected to the metal case of the electrical appliance. Then which of the following represent the largest flow of current? We have to identify the largest flow of current. So the current by definition is equals to rate of flow of charge. So in option A, we have 10 coulombs of charge in 10 seconds. The current would be equals to 1 ampere. In part B, we have 50 coulombs of charges in 10 seconds. So current would be equals to 5 ampere. Similarly, option C and option D, 20 coulombs of charges in 120 seconds and 100 coulombs of charges in 180 seconds. So the largest amount of current flowing is in option B, that is 5 amperes. So option B is our correct answer in this question number 30. Let's move to our next question, that is question number 31. Question number 31. The following diagram represents a wire carrying current I. If it is placed in a magnetic field, then in which direction will the wire bend? So we have to find the direction of force acting on this wire. So for the force, we know that a rule that is known as Fleming's left hand rule, in which we pronounced as FBI. Force is represented by thumb, magnetic field B is represented by the forefinger, and I, that is current, is represented by middle finger. So this is north to south, and this is the direction of magnetic field, and this is the direction of current I. So for finding the direction of current magnetic force, we will apply the Fleming's left hand rule. Place your forefinger in the direction of magnetic field and your middle finger in the direction of current. Your thumb, that is acting upward, will be the direction of magnetic force. So option A is the correct answer. Then we have question number 32 and 33. Which of the following scientists is famous for determining the direction of force by the left hand rule? So, as we have applied the rule in the above question, Fleming was the one who described the rule for finding the direction of magnetic force. So, option D is the correct answer. Which of the following correctly describe the working principle of transformer and AC generator? So we know that transformer work on the principle of mutual induction, and the AC generator produces induced EMF by the process of electromagnetic induction. So option C is the correct answer that describes the working principles of transformers and AC generators. Let's see question number 34. The combined forces created torque on a current carrying rectangular coil. The current flowing through the same segments are, so as we have studied in our diagram, that this is, if this is north pole of the magnet, this is south pole, and this is the rectangular coil that is placed between the magnetic field. If this is the direction of current flowing through this coil, so we know that at this part of the coil and this part of the coil, the current and magnetic field are opposite to each other, parallel to each other. So force cancel out the effects, or there is no force acting in this part. So these the opposite two parts, that are part A and part B, in these two parts the force is acting that rotates the coil in clockwise or anti-clockwise direction. So the difference between the force acting in these two parts is such that the direction of the force in these two parts are opposite, while the magnitude remains same. So option C is the correct answer, that the opposite parts of the armature of the or the coil, the forces acting on them are opposite to each other. Let's move to our question number 36, or we have 35. In the given diagram, a bar magnet is pushed into the coil of the coil in a wire. The coil is connected to the sensitive galvanometer that detects a very small amount of current. What will happen if the bar magnet is pushed through the coil? अगर हम इस बार मैग्नेट को इस कॉइल के अंदर पुश करेंगे तो क्या होगा? So with the motion of that magnet in nearby coil, there will be a change of flux in the nearby coil, and that induces an EMF, induced EMF in that coil, and a galvanometer will show some deflection. So let's see which answer is correct. Current is detected provided the magnet moving to and fro in the coil. So option C is the correct answer. The bar magnet moving to and fro around the magnet, around the coil. Till then, there will be an induced current in the coil or solenoid that will be detected by the galvanometer. So option C is the correct answer. Then we have question number 36. We have to identify the logic gate by using this simple diagram. So as we know that this represent the AND gate and this represent the NOT gate. So overall, this is our NAND gate because and NOT forms NAND gate. Then we have question number 37. The output of OR gate is 0. OR gate gives 1 when their inputs are, if its inputs are 0 1 1 0 or 1 1. If any of the input is 1 in OR gate, the output is 1. If all the inputs are 0, the output of the OR gate is 0. So both of the inputs should be 0 in OR gate to get the output equals to 1 or equals output equals to 0. So this option C we have is the correct answer. So let's quickly move to our question number 38. Which of the following gates belongs to the given truth table? So we have a truth table in where all the inputs are 0, output is 0. When all the inputs are 1, the output is 1. So as we can see, all input 1 and output is 1. So this is our AND gate. AND gate performs such a way that if for output to be equals to 1, it's all of the inputs should be equals to 1. Otherwise, its output is always 0. Then we have question number 39. The diagram shows a beam of electrons entering into the region between two charged plates. In which of the following direction will the electron beam will deflect? So as we know that electrons beam are negative, and negative beam will be attracted towards the positive plate. So positive plate in this diagram is upward. So this ray beam will be deflected in this way towards the positive plate. So upward in option A is the correct answer. Then we have the last question of this year, that is question number 40. Which of the following shows the correct input combination of logic gate Q where the inputs are X and Y? So as we let's identify the logic gates that are used. So this is our NAND gate, and this is our AND gate, and this is also our AND gate. So for 1 and 0, the output of the AND gate, what will be the output of AND gate? So AND operation is such that 1 0 will give 0 and the NAND gate will give 1 0 as equals to 1. So the output of this NAND gate goes to the input in this AND. So this input is 1. So the AND gate gives 1 when all the inputs are 1. This means that this is also 1 and the output of this is also 1. So this is our AND gate and its output is 1. It means that the values of X and Y should be equals to 1 to give output as 1. So values of X and Y should be equals to 1. So option D is the correct answer. So this was the last question of our theory paper. Let's come to our next question that belongs to our ATP exam. We have question number 41. If time taken by a pendulum to swing from its mean position to extreme position is y. That is 1.5 seconds. We have to find the time period of this simple pendulum. So let's say this pendulum starts with this position A. It moves to the mean position and takes 1.5 seconds. Then it moves to the point B, that is the other extreme position, and it takes 1.5 seconds to move to this point. Once again, this pendulum will move to point X and then point Y. In each case, it will take 1.5 seconds. So, this will complete the one vibration of this pendulum, and the time required for this one vibration will be equals to time period. So, overall, this pendulum will take 6 seconds to complete its one vibration. Option C is the correct answer. What is the value of G when the length of the pendulum is 44.9 centimeters and time period is 1.35 seconds? So the formula for the time period of a simple pendulum is 2 pi square root L over G. So for the value of G, it will be equals to 4 pi square L over T square. So if you substitute the values for 3.14 square multiplied by length is 44.9 divided by t square, that is 1.35 square. So after calculation we will get 971.62 centimeters per second square. So the correct answer we have is option C. So this was our question number 42. Let's see question number 43. What is the value of refractive index of the medium Y in the given diagram below? So the value of refractive index is equals to sine of I divided by sine of R. The value of sine I is 53. So sine 53 divided by sine of 38. So this is our incident angle, this is our refracted angle. The values of these sines are already given. Sine 53 is 0.3959 divided by 0.2963. So the value of this ratio will be 1.33. So the correct answer is the 1.33, option B. Let's see question number 44. For the diagram below, which of the following parts are labeled correct? So the first part is the one that is ray coming towards this glass. So this is our incident ray. Similarly, this part 2 is our normal line, while this part 4, this is part 3. This part 3 is our refracted ray, and this part 4 is our emergent ray. So incident ray, normal, refracted ray, and emergent ray. So this is incorrect because the first one is normal. So this could not be true. In option B, one is incident ray, two is normal, three is reflected ray, and the fourth one is emergent ray. So option B is also incorrect. Let's see the other one, option C. incident ray, normal, refracted ray, and emergent ray. And option D is incorrect. So this option C is the correct answer for this question. One is the incident ray, second normal, third refracted ray, and the fourth emergent ray. Then we have question number 45. In the given diagram, the image distance is given by which of the following uh, options? So this is our object and this is the image. So the object is represented by P and the image distance is represented by Q. So in this case, this R is the distance of object from the lens. So this is object distance, and this is the image, and from this point to the lens, this is called image distance. So according to this diagram, image distance is represented by S. Option B is the correct answer. Let's move to our question number 46. In the given diagram, the potential difference between X and Z. So as we can see, this is the series circuit, and in series circuit, voltage is divided. वोल्टेज सीरीज सर्किट के अंदर डिवाइड हो जाता है. सो दिस इज इफ दिस इज 12 volts and this is V1 and this is V2. So this 12 volt will be divided among these two resistors, and if we add these two, the sum should be equals to 12. So point X and Z, between these 2 points, these two resistors or loads are connected where this 12 volt is distributed. So sum of these two will be equals to 12 volts. So correct answer is option D. Then we have question number 47. The circuit diagram shows contain an unknown component X hidden in a box. The voltage current graph for this element is shown, that shows a straight line is shown by this component X between voltage and current. So we know that voltage current graph is always a straight line for a metallic conductor or an ohmic conductor. So this element X could nothing be else than this ohmic conductor, because the voltage current graph is obtained a straight line. Option B is our correct answer. So this was our question number 47. Let's move to our next question, that is question number 48. What is meant by magnetic field of a magnet? What is, so we have to define that what is magnetic field. So as this electric field is defined and as gravitational field is defined, so the field of force is a region around that object through which it can apply the non-contact force. The region around the charge is the electric field. The region around the earth is its gravitational field. Similarly, the region around a magnet is a magnetic field, and the magnetic field is the region through which a magnet can attract or repel the in other object or magnet. So space around a magnet where it magnetic force, magnetic properties can be felt. The attractive force that a magnet exert on the other magnet, the repulsive force, and the space around a magnet where the space around a magnet where its magnetic properties are strong. So the correct one is option A, that the region around a magnet where its magnetic properties or the magnetic force is felt. Option A is the correct answer. So this was our question number 48. Let's move to our question number 49. In this circuit, the switches are closed and the LED is lit. Which action will turn off the LED? So we have to identify the action that turns off the LED. It's mean the current should stop, and the or the output of this OR gate should be zero, and the output of the OR gate is zero when both the inputs are zero. So both both switches, open switch 1 only, switch open switch 2 only, and keep both the switches at the closed position. So this is the closed position, so we have to open the switch so that it gives zero input. So option A is the correct answer, that both switches should be opened. Then we have question number 50, that is the last question of this examination paper. Which of the following will not light up the LED? So this is our LED and will not light up the LED means the output from this NAND gate is 0. Output should be equals to 0. So if we recall the definition of NAND gate, that let's see first what is AND. The output of AND is 1 when all the inputs are 1, and the output of the AND gate is 0 when any of the input is 0. So this is the truth table of our AND and NAND gate. The output we need is 0 because this LED will not light up. The output of NAND is 0 when the both of the inputs S1 and S2 are 1. So both switches should be closed. For closed switch, it is equals to 1, and for open switch, it is 0. So in this case, to gain the output 0 from the NAND gate, the switches S1 and S2, both switches should be closed. So the correct option, close both switches S1 and S2. So option C is the correct answer for the last question of this examination paper.